Okay, well, my apologies for this late start, but still, I want to congratulate and compliment, in fact, Steve Young and his team. I've been involved with them in their program for several years now. It's been a joy. It's a really prodigious program, to say the least. Um, so, in any case, let me get you into this thing to play. Okay. I'm going to focus my first remarks here on the so-called science model. I've been in this business for a long time. I did my first research in 1957 when I was in graduate school, quite a long time ago now. And it was actually in this area, just taking the gut contents of a chinchilla animal, putting into a rabbit to see if I could change his dietary fiber digestion. And sure enough, it doubled it. It was very, very exciting, really got me hooked. But in any case, so I'm in the space called science, as you may know. And science has a very special meaning for me because this is all new territory for me at that time. I mean, I didn't really know anything. But getting into the science model, I saw some very exciting opportunities to learn things. Let me start off then with a statement that I've recently seen written by Neil Tyson, who's the director of the Hayden Planetarium. It really fits perfectly what I've come to believe too. We own opinions, we don't own facts. I really like that statement because what it really says, especially in territory like this, let's try to get the facts that none of us own. They're just plain facts. That's just that simple. So research, experimental research, if you will, which has occupied most of my time, really is converting opinions into facts. And so just to give you a little more information on that idea, we start out with an uncertain observation. We become curious, skeptical, whatever, and we want to know something about it. And that's why we started research. And I'm talking about, when I talk about research, I'm talking about experimental research in a laboratory, actually formally investigating this particular question. And so that's more or less the first stage. And then to formalize this activity of learning something, we make a hypothesis, make a suggestion, essentially, of an explanation for the thing that we're seeing, this uncertainty. Then, of course, in due course, sorry about this, I got to pull down just out of the way here. Okay, so we do research that most importantly is transparent to everyone. We don't do it in secret. We do the research, and we're expected to share what we're thinking and how we're doing it with anyone who wants to know. And in that research effort, one central ingredient is to control our biases. And that means especially our own personal biases. So those are two really important features. I've rather liked it because it kind of removes the personality part of personal feelings out of it. And so this is the model, in fact, that NIH uses, who funded all of my research over the years. So we do the research, and then we get the results, make some interpretations and findings. And then we submit it for professional review. At that time, publish it, and then it becomes so-called peer-reviewed literature. I'm telling you this because I've become troubled, quite frankly, about what has happened in the plant-based community over the years. It was back in 1990s, actually. I was attempting to teach a course in this sort of area, and I got some funding to invite a total for the next 6 years, a total of 32 visitors, speakers. And and 6 of them were said to be vegan, vegetarian, if you will. And so I was really interested in bringing in some colleagues at that time to kind of share these experiences that I've been having for some 34 years with this concept called vegetarianism. And a number, as I say, I brought in 32 altogether over that 6-year period. And there were several that came in and learned some things, and somehow I didn't succeed because they left, went to do their own thing. And one of them got involved in talking about supplements as a means to nutrition and trying to sell some supplements and then put my name on some of their papers. It was really kind of an ugly situation, to be honest about it. Another one wanted to talk about the question concerning the morality of eating animals, which is fair enough. I came from a farm milking cows, and so that was kind of new to me, but nonetheless, that's a fair opportunity to do things. But then once they get into that thing, and if that's the only thing, and we don't talk about science, kind of loses me. And then still another person that I had to come in here at the time went off and then started collecting a lot of isolated facts, if you will, and then talking about them, one by one by one by one. It doesn't work that way. That's not the way that nutrition really works. And we because then we end up sort of choosing the fact we may want to have some personal liking to, and talking about it in essentially in isolation. What it turned out for me in this whole effort over the years is that the kind of things that go on in our body from a biological perspective, from a biochemical and physiological perspective, which is my territory, what I came to know, or to really come to believe, was that all these things that are going on that we talk about from time to time, and there are zillions of events and factors and causes and outcomes and stuff like that, in reality, they work together. They work together. And by taking out one at a time, as call it a fact, and then going on and making a big discussion about one fact as if it's acting in isolation, that's typical of the entire clinical and medical community, which I don't particularly care for, but it's the way it is. So this is science, and now I want to show you some of the key things that I did with the years to get me into this space of so-called science. The end game was, after some time now, I end up with this here expression here about nutrition, and I have a very different perspective on nutrition when it's typically told. And when I say typically told, I'm talking about my own community in nutritional science, nutritional biochemistry, but it's also very different from the medical community, the clinical community. And so I'm summarizing here just quickly, and I'll come back to this, that nutrition is best seen and understood and explained, if you will. Understanding, first off, there are multiple nutrients in food. They're involved in processes in our body, whether it's creating disease or curing disease or whatever it's doing. A lot of nutrients. I'm talking about not just a few dozen, I'm talking about thousands, millions of, when you talk about nutrients and the analogs that they may have. Quite frankly, kind of working together. That's the exciting point of view. And each nutrient tends to use multiple mechanisms to do its work. So that combination of all these nutrients, endless nutrients, and each one of them have endless mechanisms to work. It's like a cloud. They create a cloud and it creates a response. And then in turn, it affects multiple disease endpoints. We shouldn't be divided up disease so much. I mean, it's helpful to some extent to know the difference between heart disease and cancer, of course, or something like that. But in reality, we take away, when we do that kind of thing, talking about one at a time, we take away the perspective on comprehensiveness, when in reality, nutrition operates comprehensively. So, working on one disease at a time, I say, it's kind of helpful in a way to learn things, but we shouldn't lose sight of the fact that what may work for one obviously may work for a whole lot of others. And that's where I ended up, at least. And of course, in the end of the day, we prevent a variety of diseases and we see multiple health improvements. And so I ended up, as was explained in the intro, that with this concept that I rather liked, that I call whole food plant-based. That statement there, for me, it represents the comprehensiveness I'm talking about. And also at the same time, it's simple. I mean, I think this idea of nutrition is really quite simple. It's been made complicated by all the factors we tend to focus on one at a time, which is crazy. So in any case, I call whole food plant-based diet, and I'll come back and make that the point of my discussion here, whole and plant-based, those two concepts. Okay, so now, again, for a little bit of background, I came from this into this story from a radically different point of view. I was raised on a farm, milking cows, and I was a hunter and fished and all that sort of thing. So when I came to school and finally eventually in graduate school in Cornell University, I did a thesis, my doctorate at least, on a thesis of encouraging animal protein consumption. After all, that's what we do on the farm. We make milk, we eat meat and so forth. And So I ended up doing a PhD thesis on essentially working with cows and sheep, if you will, encouraging a means by which I don't want to go into that, a means by which we should consume more animal protein. Animal protein is supposed to be high quality, so it was said. So after my graduate training, then and a couple of years at MIT, I then was at Virginia Tech, being responsible, coordinator, I should say, coordinator of a project in the Philippines run by the State Department on developing a model for feeding malnourished children. And at that time, the United States seemed to have had a kind of particular interest in this area in large measure because the dairy industry was able to provide dried milk powder to feed these kids. In any case, we had to develop a program to feed these children. And that was about that time, this is 1960s, by the way, about that time, this study came out from India on a rat study, an experimental rat study. And the results are spectacular, dramatic. Namely, they were looking at the effect of protein fed at two different levels, 20% of calories, that's high, more or less, regular to high, or 5%. And so they had two different levels of protein feeding. And then they, in turn, had animals that were destined to get cancer of the liver. It starts out with so-called hyperplastic nodules and finally form tumors. But in any case, you can see the results there. The animals fed 20% protein, 100% of them got the cancer. The ones 5%, none did. How in the world can this be? I mean, I just saw this. This is not possible. We had kids to feed. We were expected to make sure they get enough calories, first and foremost. But secondly, we were expected to actually emphasize the consumption of protein, good quality protein, like animal protein, if you will, which is consistent, as I say, with my thesis, my own personal background. But here you can see this. The Indian workers themselves did not believe this, the researchers. They went back and did it. They changed the study design a little bit to try to prove the opposite. But I won't go down that road for the moment. Just here's what they found, that the animals fed the so-called regular or higher levels of protein, 100% got the tumors. And then, it really, this brought into this question, as I already mentioned, that, I always thought, like everybody else, especially in my PhD thesis, that increasing protein was a good idea. But here, it's looking like increasing protein increases cancer. Really striking. So I had no choice left, because here we had children to feed, you're supposed to get good quality protein, that sort of thing. I had to really get involved in doing research. And that was the beginning of my research when I applied for a grant with NIH. And I got the grant. In fact, I was really lucky to have gotten successive grants over the years, 100% of the time over many years. So this is NIH funded, I should say. And so we started out doing the research to mimic the India study and looking at the formation of the cancer within the first 12 weeks. And you can see on this plot here, the cancer starts out with a gene mutation, okay? We all assume that. Cancer starts with the mutation of the DNA, if you will, the mutation of the gene. And then you see the cancer index on the y-axis. And so we just watched to see what happens over that first 12 weeks. Mind you, I was really interested to see whether or not this Indian research was correct. And so 20% is growing in cancer very well, as you can see there. 5%, like they used, it did not. I mean, again, it was striking. I can't emphasize this enough. The Indian work had shown that 20% protein actually was associated with a higher level of cancer. Not by a little bit, 100 to nothing, essentially. So then we tried something else with my students, and most of them who were working for the doctoral dissertations. But in any case, I was interested in seeing what happens if we turn the cancer on and off, by way of changing dietary protein intake. And as you can see here, we fed 20% protein, and cancer is growing quite nicely. Give them 5% the next 3 weeks, turn it off. In other words, a really responsive kind of thing. Turning it on, turn it off, if you will. Turn it back on again. Off again. This was, to me, this was beyond the pale. But here, the cancer starts with the gene, like we all assume. But in this case, the development of the cancer thereafter is a function of how much protein is being fed, or in a broader sense, what is the nutritional conditioning, if you will. So we can turn it on and turn off cancer. As I say, for me, that was almost a starting point for my real keen interest in this area of research, because who can believe this, that cancers can be so easily turned on and turned off very simply by a nutritional means. Admittedly, this is experimental animals, but that's what most research does, and in that sense, and so it eventually led me to look at humans, obviously. In a general way, what this also says is that nutrition, not the genes, controls cancer development. The reason I make that point, because this is a big deal. The cancer industry throughout the years have assumed that cancers all start with whatever affects gene mutation. That's where the idea comes from, with chemicals causing cancer. It starts out with changes in mutation. Well, in this case, it had nothing to do with that. In this case, these animals the genes are all mutated. The question of whether or not the cancer occurs or not is a function of nutrition, turning it on and off. Okay, that was I can come back at that several times as we go forward, but that was a big, big observation. So, but that was only for the first 12 weeks. So then eventually, we wanted to see what this might have to do with the lifetime of the animal. And I had another student in this particular case doing his research, 5%, 20%. And you can see over in the right-hand column there that the tumor severity, number of animals used. The tumor severity, look at the 20% compared to the 5%, huge, almost the same thing as 100-0 score. I mean, make no mistake about it. The protein turned on the cancer, and it really did it about as much as it possibly could merge about it. And the 5% animals feeding the lowest level of protein, they're all living 100 weeks. That's the lifetime. That's the lifetime for a rat. They're all living at 100 weeks. The animals fed 20% are all dead by 100 weeks. I mean, who can argue with this? This is really incredible. We can turn cancer on and off by nutritional means, simply by giving high protein, and it lasted for a lifetime. Okay, so the next point I would like to make, I'm skipping over a lot of research in between, but nonetheless, hitting the high points. I became interested in this question concerning the role of plant proteins in doing this. So eventually we got around to testing a couple of plant proteins, soy protein and wheat protein, on the early cancer development. And it turned out, even when these plant proteins were fed at 20%, which turns on the cancer is 100%, and given a plant protein, it did not increase the cancer development. So all of a sudden, here was a picture. Animal proteins do one thing, plant proteins do something exactly opposite. Stark, absolutely stark. So then it raised the question, at least for me at that time, was let's go beyond the question concerning whether or not animal proteins cause cancer. Imagine that really spooked my colleagues and told me not to go down that road, early in my career. So it was a very sensitive issue. The idea that animal protein, high quality animal protein, like cow's milk protein and so forth, could turn on cancer beyond the pale. I wanted to know at that time too what effect it might have on other diseases, and also wanted to know too whether plant proteins could do the same thing. So I'm going to summarize here in this slide here something that got me into the business of finding out, since this result was so staggering, so remarkable, what we want to do in this kind of area is we want to know, is it plausible? That's what we usually say. What is the mechanism by which this occurs? So what I'm showing here is a search for the possible explanation of why this occurs. And this involved a number of different students over the years. For about 12 to 15 years, we were working on this. And I was at that time, I was primarily focused in pharmacological kinds of research as opposed to nutritional research. But I'm showing you here in the scheme on the left, the question concerning the development of early cancer, or cancer as a whole. It's schematic, obviously. It starts out with 3 phases. That's the way we tend to divide things up. Starts out with initiation. That's when the mutation is forming. Then the cells, once mutated, then the cells start dividing, and that's during the growth phase or promotion. We call it cell expansion. Finally, we get to a point, especially in the case of humans that we know well, the cancer is migrating or metastasizing into some other tissue. That's called progression. So we have these three sort of arbitrary stages of cancer development. I'm showing it twice here. Showing the chart, the first chart at the top and then the bottom chart. And we're looking for the mechanism by which this animal protein effect is existing. And so we found some things in the aggregate over, say, about 15 years or so. First off, I'm pointing out the initiation. There's one here on the left. I'm trying to get a pointer. I don't have a pointer for this, but in any case, on the left, you can see that during the initiation stage, when the mutation is forming, the high protein diet increases the rate of entry of the carcinogen into the cell. I mean, that's a lot of work. What I've tried for years to really point to prove that point, but it increases the rate of entry into the cell. And so, oh, that's what it is. Now maybe we can make a drug. We can make a drug to block the entry into our whole free. We can still use the diet we want to use. But then we kept on looking, as I say, I had this opportunity to do these different things in part because I had a number of students who are coming in and wanting to do their doctoral dissertations. And so otherwise I probably wouldn't have done it quite that way. But in any case, on another occasion, I wanted to see, what effect did this high protein diet have on the enzyme inside the cell that actually modifies the carcinogen? And what we learned was the high protein diet increases the activity of the enzyme that activates the carcinogen. It also changed the structure, two different ideas. And so it went. And then it increased the binding of the product of that metabolism to the DNA. That's the mutation thing. And of course, then we have mechanisms by which we can repair this stuff. This is going on in our bodies all the time, I can assure you. We get exposed to chemicals that might have the property of causing cancer. Unfortunately, we have something in our bodies that works all the time. It's called DNA repair. It's part of the immune system, actually. And so what the high protein diet did in this case was to actually just, decrease the good thing that we had going for us. So it increased four of them, decreased the good one we have. Now it's just during the first stage. So eventually they went to the second stage, which is reversal back and forth. You sort of know that. And again, it decreased an activity that's good for us as immune activity called natural killer cell activity. I'll get back to this in a moment. And then increase the rate at which the cells divide, increase the production of free radicals, which stimulate cancer and so forth. The growth hormone. I don't want to dwell too much time on that. Just simply to say, there's a number of mechanisms here. And so as I was working with this, I should say with my students, I wanted to do a project, maybe it would take 2 or 3 or 4 years or so. I wanted to still looking for this mechanism. Which mechanism is really, what kind of counts for this effect of animal protein on cancer? It turned out at this point in time, I finally got to a point where I realized that every time we looked for a mechanism, we found one. Can you believe that? Every time we look for a mechanism, we found one. So it basically questions, if we develop a drug to try to block one of these things, is that going to do anything with all the others working? In summary, we increase the high protein diet, increase the activity of 8 mechanisms, increase our activity rates, all led toward cancer, if you will, and actually decrease the 2 mechanisms that are there for us to protect us. One is DNA repair, you see in the top chart. The other is it decreases the natural killer cell activity. So at this point, we've got 10 mechanisms, really researched quite well, quite published, all of that sort of things. We're quite satisfied with it, but then they're still looking for another mechanism we might study. And it occurred to me, wait a minute, there's something wrong here, with it's really fundamentally wrong with our thinking. Namely, as I say, increased 8 of the mechanisms, those are all in the white, and decreased 2 of them in the yellow, okay? But they all did the same thing. They all did the same thing in effect, all 10 out of 10, no exceptions, no exceptions. So that led me to a rather different idea. It got me going down the track of what is nutrition? I mean, nutrition is when in the case of animal protein, in this case, and not plant protein, but in this case, it turns out that when the protein starts to act animal protein to increase cancer, among other diseases. It doesn't just do it by one mechanism. That's the stuff for the drug therapists who want to find a drug. No, that is not the thing that we're talking about here. It increases all of it at the same time. It's the nutritional effect. So as to which mechanism really important, I couldn't say which one is and which one is not. Therefore, the idea of even theoretically sort of developing a drug to block one of these things is kind of silly. It gets any place. I'll talk more about that in my lecture tomorrow. So animal protein in reality increases cancer dramatically and actually turns on the prostate very fast, and it's biologically plausible, which is the concept that we like to research to see whether or not something we see whether it's really plausible. So there you have it, really shorthanded, brief description of what we found. Now let me turn your attention to something else here. Can jump ahead a little bit. Animal protein is so revered throughout the world, and here's a plot by the group in Washington, World Bank data, that shows the relationship between animal protein intake in this particular case and of all things, how much money we make. I really got kind of caught up in this whole idea because I've been working with my friends in China at that time, and so they wanted to increase animal protein intake like we do here because we're rich and so forth and so on. So around the world, people have this concept, usually unspoken. They don't even know they have the concept. They're kind of silent, but they want to get an opportunity to eat animal foods. And the justification for that is to make sure they get enough of that good protein. That's what people, as I say, world over, we have that, especially in the third world. They want to get rich, and they think one of the best ways to do that, if they can just make enough money, then they can buy an animal and eat the animal, or eat the eggs, if you will. So here's a plot. I mean, that's really impressive. That's my line on it, but it's a straight, we call it linear regression line. The higher the income, the more animal protein consumed. I'm going to come back to that later on, but I just wanted to tell you this because this is a fundamental kind of hidden motivation, rather expressed, obviously in many cases, but it's an expression of a thought that we all have, that the more animal protein we get, then we can become rich. But in reverse, it turns out when we get money, we buy the animal protein. However, it's not, in terms of making a recommendation, we can't say, oh, it's animal protein. That's it. That's the problem we have here. No, it turns out that I came across, and I'll talk about this in the second lecture, is there's a couple of these going on. They're complementary, each one with the other. Namely, as we increase, like a seesaw, well, let me say first at the top here. It said the first recommendation I end up with is eat plants, not animals. I mean, I have enough data. We were on the typical Western diet ourselves, and we started to change just because this data was so dramatic. And there's other reasons for saying the same things I'll show you in a moment, besides just cancer. But in any case, just eat plants. There's no point in eating animals. We have no need for the so-called high-quality protein in animals. That's been a misrepresentation for years. So eat plants, pretty simple. A variety, whatever you like, just eat plants and try to eat them then in the whole food form. That's the second part of the story. Rather than taking out individual nutrients, that doesn't work. That's not the way to do it. Make them into supplements. No, that's not the way it works. Eat plants, eat them whole, make your life simple. You got all kinds of variety, endless variety. It's all about the person in the kitchen fixing the food to see how good it is really the important person in this equation. So when the animal food goes up, as we increase the animal food in our diet, we decrease plant food. And they both do this, both of those changes produce the same thing. Animal food, as it goes up, it increases risk for disease. Plant food, also, as it goes down, it also increases risk of disease. So an increase in animal food, decrease in plant food, doing the same thing. So then if we see, let's say, correlations of animal food consumption with various diseases, we have to keep in mind it's not just the animal protein, really important point, or the other nutrients that go with it, like saturated fat or cholesterol. It's not that. It's a combination of things on that end of the seesaw, as opposed to in addition to the decrease in consumption of the things in plant food that really help us to stay healthy. Okay, now I'm going to show you. I did collected these data here maybe about 10 years ago. It came to my attention. I knew some of this over the years, but not as well as I came to know them. I want to show you some plots of researchers, other researchers during the last, it was back in the 1950s, actually. I will show you in a moment. And just show you something that really is interesting. These are screenshots. I didn't make these data up. This is what others have found. The one here by Armstrong and Dahl is Sir Richard Dahl in England. He's the one that actually wrote the foreword for my China study, the big study, and very famous fellow, epidemiologist at Oxford. So anyhow, in 1975, he got together with a younger fellow, Armstrong in Australia, and they would look at the relationship between animal protein intake and renal cancer, kidney cancer, for these different countries. Look at that. I drew the regression line just to use a metric to maze to do that properly. Equal numbers of sides, more or less on both sides of the line. But you can see it's a straight line relationship. There it goes, all these different countries. That study was done in 1975. Notice the US is pretty high up on the list, the third highest, essentially, if you will, something like that. Here's one that then came out in 1959 by a gentleman, again, an English researcher working in Jamaica at the time. Look at the relationship between heart disease, mortality, deaths, if you will, again, for a bunch of different countries, with percent animal protein. See, it's 1, 2, 3, 4, and that's on the x-axis. You can see here, as animal protein consumption has increased, we see an increase in heart disease mortality. So now we got kidney cancer, we got heart disease. What's going on here? I mean, these lines are really impressive. No one will ever come along, I can tell you, and find something in reverse. This is what I'm talking about, facts that we don't own. These are just facts. We have to live with it. That's what it is. Increase animal protein, we get more kidney cancer, really quite remarkable, if you will. And we also get more heart disease mortality.
Hi, Dr. Campbell, can you raise your webcam a little bit?
Pardon?
Perfect. Yeah, that's fine right there.
Yeah.
That's great.
Okay, there we go. So now the third one, prostate cancer. This was done in the 1980s by someone I know, acquaintance, not a friend, but in any case, he looked at the relationship between, of all things, non-fat milk and prostate cancer and got the same thing. Those are all countries, different things. The same line sort of appears. And non-fat milk, by the way, and that's what, he sort of concludes that, as any of us would at those times, non-fat milk is not so good, skim milk, if you will. Low-fat milk, non-fat milk can raise the risk for prostate cancer. That's pretty dramatic. But basically, let me suggest for you thinking, it's not really a non-fat milk. There's obviously very little or no fat in that product. There's really very little sugar. The only thing you're left by way of energy is protein. So it's a protein drink. It's an animal protein drink. We see the same thing in this third example as we saw in the others. Increase in animal protein, if you will. We see an increase in prostate cancer. Again, really quite dramatic. No mistaking about this. It's a fact we just have to live with. Okay, here's another one. Here's breast cancer mortality. And this is a friend of mine from Canada at the time, a good friend, researcher. At the time, we traded talks and seminars. But in any case, what he was comparing here was a bunch of different countries with respect to the risk of getting breast cancer deaths, if you will, breast cancer deaths, with saturated fat intake. Because in those days, he and others thought that, this whole thing that as far as nutrition is concerned is really about saturated fat. It's bad. That's wrong. That's been known for over 100 years. Very few people know that, but it was a mistake. In any case, he put saturated fat on there, assuming that might be the cause, when in reality it's a representation of animal protein intake for different countries. Notice here the first four that I've got. The U.S. is near the top in these different cases here. So we consume more saturated fat, which comes from animal food. Just a representation is an indicator of animal food, animal protein fuel, more breast cancer mortality.
Dr. Campbell, can you raise your camera one more time? Sorry.
Yeah,
It keeps on dropping. Awesome. Great.
Yeah. So now here's another one. This is on heart disease, mortality, if you will, with of all things, not animal protein in this case, but with cholesterol intake. You know how everybody thinks that cholesterol causes heart disease? No, it doesn't. I mean, it might play a small, minimal role in advancing the disease, but it's not the cause of heart disease. And that's another whole story in itself I can tell in due course. But in any case, as we increase the consumption of cholesterol, as shown here on the y-axis in this case, we increase the risk of heart disease, mortality, death rates. Look what the U.S. is, number one, right at the top. Again, we see the same thing. This line, this regression line, as I say, put that line on it myself. These researchers did not do that because they were thinking about one thing at a time. So here we got a regression line like the others, go right down, right through the XY origin almost, suggesting that the moment we start consuming cholesterol from animals, that's where we get it from. As soon as we start consuming that, then risk of heart disease starts to go up. And it's a huge difference, as you can see when you compare all the countries together. Here's one for colon cancer. This is pretty straightforward. Meat consumption with, in this case, meat consumption is animal protein mainly, and representing the same point that I'm making here is an increase in animal protein intake. Different countries again. Notice where the U.S. is, right at the other top, right? Right at the top again. And I mean, this line here is really remarkable. All these lines are. What it says in a very convincing way will never be shown otherwise. I'm not just pulling things out of the thin air. This is reality research of other people. As soon as we start putting animal food in the diet, we run the risk up on all these different diseases. And there's more, by the way. Here's one on urine cancer. They looked at this and represented it as total fat intake, and therefore they concluded, like everybody else would, that total fat is related to uterine cancer incidence. No, total fat in this particular case is correlated in 0.94 across the different countries around the world. Total fat intake is pretty much a function of animal food intake. Again, the USA is at the top. So we start eating animal food, less plant food, obviously. We get much more urine cancer. Look at all these different diseases appearing. And so anyhow, I got some more slides. I just want to make the point that as soon as we start increasing our consumption of animal food in our diet, and therefore decreasing plant food, so a lot of the effects of plant food, by the way, but as soon as we start, believing that idea that animal food is important because animal protein, then we get these diseases. And so I'm saying that all these representations here, although they point to different nutrients and different foods maybe and so forth, that they're really all surrogates of animal protein. Because those things alone, they do not do the things that otherwise. So that's for animal protein, not plant protein. You'll see here, this chart here I put up here this is my friend from Canada that did the saturated fat thing. He also put on unsaturated fat, which is present in plant foods, and it's always said and believed that unsaturated fats are good and saturated fats are bad. That's wrong, by the way. So as we increase, I put a thing on plant protein in there. It should have been unsaturated fat. I was doing for another reason. As you can see that as we increase the consumption of plant protein, we don't get a relationship. We don't get it. We only get it for animal foods. So now, just for a point I'd like to make here involving all these charts and some more, the bone fracture rate, and my gosh, there's some others. I just wanted to show you enough here that is so common. Namely, there's some common features about all those charts. First off, the United States is at or near the top on disease rates for all of these because we eat the most protein, animal protein at that. So we're very tightly coupled with that idea. And it turns out the highest rates, if we look at these charts in the aggregate, the highest rates versus lowest rates, it turns out the highest rates are 10 to 15 times higher than the lowest rates. I mean, it's quite a bit. And several of them are a lot more than that. I'm really being quite conservative here when I say it's at least 10 to 15 times higher. So what it says in theory is if we were near the top and we did what the countries did near the bottom, we could practically eliminate all these diseases, if you will. Which suggests that most of these diseases can be prevented, even reversed, I should say. And a third point that I want to make about those charts is that the linear regression, those lines that I was drawing in those charts, goes essentially through the origin, the XY origin, which means in theory that as soon as animal protein is put into the diet, changes in plant food too, we get less disease, almost zero disease. In theory, that's what this basically is saying. So it really puts a seal almost on the idea. Animal protein consumption, I'll get into this later, is thought to be very important because I call it, that's untrue. We've been living with that for over 100 years. And in reality, when we start to put that kind of stuff in our diet, we're going to get an increased risk and dramatically increased risk in many cases for a lot of these diseases. So I'm suggesting this, and I don't have time to get into this worth a whole seminar, but basically disease prevention, these kind of diseases and others, or reversed, such as what Dr. Esselstyn did with heart disease, for example. These diseases can be not only prevented if we do it the right thing, but in many cases can actually be reversed if we switch. And I'm saying that a minimum of 90% of these diseases can actually be brought down to a very low risk and not get them at all, and in a lot of cases actually reverse them if we choose to change our diets. I just find this whole idea really almost staggering. And it's something that it's an observation, I would say, that will never be shown otherwise. It's in that territory called facts, because you can't find, somebody's not going to come along and get a bunch of countries and show to do the opposite. It simply won't happen. Okay, so we eat the wrong food. We eat lots of animal foods, and for all kinds of reasons, millions of kinds of explanations and so forth, we get this effect, all working together. So now I want to just show you. So we do that, and we use a lot of drugs. We go ahead and get the diseases, and then we're going to solve our diseases by getting a bunch of drugs. So I'm really raising a really serious question here. We live by eating the wrong food, first off, grossly. We eat the wrong food. And we hope we're going to solve our problems by, oh, there's going to be a drug this, a drug that. So we use pharmaceuticals. The U.S., in this chart here, what I'm showing, and this is the Office of Economic Cooperation and Development, the more Western kind of countries, more or less. But the U.S. here, we're number one in the use of pharmaceuticals. Here we're eating all this good food, very rich in animal food and fractionated plant foods, and that's another story. But in any case, we eat the wrong food, and we have to use a lot of drugs. That's the state of affairs in this country right now. We're using the most pharmaceuticals of any country in the world. Secondly, I put here, use only country. The U.S. is the only country who advertises on TV prescription drugs. That's not quite true. There's another country, New Zealand, has sort of done this, but I've actually been interviewed by somebody in New Zealand who says they have on their legislature right now the opportunity to stop that practice. Haven't seen it happen yet, but nonetheless, the U.S. is doing this. We advertise prescription drugs. In fact, between 70 and 75% of our advertising on TV is for drugs. So the market outfits in this country have control of our minds. They're telling us what to do. You know, to use this drug, that drug, and all we need to do is have a lot of us be sick. That makes money. So it turns out also the use of prescription drug side effects for all kinds of reasons, worth a couple of seminars on this alone. There's prescription drugs all are going to have side effects, unpleasant side effects, including death, of course. It turns out that the deaths, the side effects is a number 3, according to some estimates, number 4. This kind of trades off in that area. The cause of death in our country behind heart disease and cancer. So just taking these drugs, you know, to try to solve and reverse those diseases, the heart disease and cancer and all the rest, It's an equation. It's a phenomenon that's become our medical system. It's horrific, actually. It's dramatic. And so I'm going to suggest here for your thinking that we're featuring the consumption of animal foods and long kind of plant foods, and then we're treating ourselves with these drugs, and that's what we get for it. Another thing that I find kind of interesting in this set of data, the U.S. is near the bottom. In fact, it's last place among the more economically developed countries in life expectancy. Our life expectancy is going down. A tiny little bit at a time. We're using the most drugs, we eat the wrong food, and we live the shortest lives. Okay, put that, just think about that for a second. It pretty much is a sort of a summary pitch, I guess you could say. So this is a rationale for drugs. It seems like to me, if I want to be sarcastic about it, we advertising these drugs and not say anything about what kind of food we should be consuming, and so we die sooner. That's simple. Now I want to show you, bring this up to date in this first presentation. I'm going to be doing it more tomorrow, but I really want to share with you a recent story, especially related to the coronavirus, if you will, to show you the state of affairs. We did our study in China, and many of you may know about that. It's a huge, and New York Times called it the Grand Prix of all studies. It was a big study, and I'll be talking briefly about that tomorrow. But in any case, the one thing we did measure in China in that study was that we had information on liver cancer as a cause of death in China, more common there than here. Liver cancer is the cause of death that's caused by a virus, hepatitis B virus, really serious virus. More serious, I would suggest, than the coronavirus that we had. And so we had collected in a second version of the China study in 1989, all the stuff we did in the first one. The second, we had joined Taiwan and mainland China together to collect information. But in any case, the data I'm going to show you here comes from 1989. And so in January 2020 is when we were told about, this horrible, horrific virus that we're going to experience, the coronavirus. And the first thing they're going to do is going to get us a vaccine, if you will. And so it went. And so during the 1920s, we're all putting masks on due to this and that, everything else, and this horrible virus is around us, and etc. And so I go back in early 2021, or late actually of that year. I went back and collected data from that second China study because we had some information regarding this virus, not the coronavirus, but this virus, which is just as bad as the other one. In both cases, they're basically controlled by the immune system, I should say, and nutrition. So here we got it for hepatitis B virus. You can see there are 8,900 adults in this study. Okay, and just to show you schematically to try to simplify things, I want to show you what happens to a virus when it's out there in the environment and we get infected. And we might get it from the air, mostly from the air, if you will, or sputum from, let's say, our saliva and stuff like that on our food, in the water. So we get viruses from here and there. That's been around with us ever since we've been calling ourselves human. So the virus comes in and lands on us by different means. When it was active, that's when we test positive. That's what that means. When we test test positive for a virus, that virus is the actual protein of the virus that's circulating in our blood. It's called antigen. We had a chance in that second study to measure the prevalence of hepatitis B virus in this large population and to see what effect it had on liver cancer rates, because that's what it causes. So we measured in all these different people how much active virus they had. In other words, how much are positive. It turns out, if that virus comes into us, kind of circulates in our system, eventually this particular virus is going to cause death from liver cancer. The third leading cause of death in the world, by the way, I should tell you. So the active virus then causes liver cancer death. It turns out, I was just floored by this here. We measured the amount of animal food in different ways in China at that time. And on average, the animal protein intake, just as an indicator, the animal protein intake on average in rural China was only 10% of what we have in the West. I didn't think that's not enough to cause any problems. But it turned out people consuming even that small animal food, they were the ones who got the liver cancer and died. Plant food, in contrast, those increased more plant food consumption could inactivate the virus by antibodies. How about that? Antibodies. I mean, all these viruses work the same way, by the way. So the plant food, people consuming more plant food, they formed antibodies. And they formed these T cells. I didn't show you the data on that, but we had worked with them 20 years before in the laboratory, the T cells in this particular case, in an animal model, and we saw the same thing. But it turned out that people consuming plant food formed antibodies, and they did not get the liver cancer. It was so dramatic. And they actually increased the production of T cells and natural killer cells. You may remember mentioned before. They actually are the things from the immune system that keeps disease under control. So the plant food people, they got the inactive virus. They got it was positive. Yeah, you can't stop that. But that went to work. Our immune system goes to work and just basically inactivates the virus. People consuming animal food, on the other hand, did not do that. They did not form antibodies. They got liver cancer and they died. And I take this from data I had never seen in my career. Really extraordinary data. What we did in China in our study was have a lot of correlations. And when you treat them the right way, there's no problem with it. But I only reserved my comments to those that are significant at the highest statistical level, P001. There are 11 risk factor correlations in that study that we did that converged the same outcome. In other words, what I'm showing you here with the very high degree of statistical significance, those who consume a small animal food, they get more cancer, more heart disease, more liver cancer deaths. This is exactly what we're seeing in our studies from other sources and, of course, in the laboratory over the years. It's really quite dramatic. Of all the data that we've collected over the years, I have to say this is for me, the most impressive data I ever saw. There was one exception here, but by the way, of all the ones that were significant, this level of probability, one exception that did not quite, I have to be honest about it, did not quite make it that way. But it looked like it was a methodological error. But be that as it may, 11 of these research correlations all converged the same direction to show us that eating any amount of animal food will increase the probability of viruses going to cause us problems. So I'm learning about this. We had all this data hadn't published at that time when it first came out in 2020. We heard about the coronavirus and that, and I know that, if you can take a person with already diseased, if you will, and see disease reversal. That's what we did. My friend Esselstyn did it with the heart disease, if you will. And so my notion was that this is a replication of what we already know. That is, people consuming animal food are going to have a problem. People consuming more plant food are going to get the solution. So I sent the paper in. I was quite excited about it. And what happened? They wouldn't even review it. These are the two of the three leading journals in Western literature. I've published in both of these journals before. I've published 300 and some publications. I've been quite active in my publication over the years. And in this particular case, two of the leading journals, they wouldn't even allow my manuscript to be reviewed by the professionals. First time in my life I ever had that experience. In other words, people are in control of the science. They're not letting the science to see this. They didn't want to see this, obviously. So eventually I got it published. It was at a journal, EC Nutrition, which is basically associated with the European Union. I think the only reason I got it published was because the Minister of Health for all of Europe in that group is someone I know. He likes what I do, and I think I can't say this for sure, so I want to be careful, but I think it had something to do with the fact that it was actually published in that journal. EC Nutrition was called. There's the copy of it right here. It was published eventually in 2021. But the reason I'm showing you this is because this whole idea of nutrition being ignored, not taught in medical schools, right? MDs really don't know this there for the most part. So they don't see this. It's all, as I say, it's controlled. And in this case, we're seeing the same kind of diet that reverses heart disease, prevents it, prevents cancer, reverses all those other diseases I just told you about. We see the same thing for viruses. And the title I sent in there was a mistake. I put a nutritional link for COVID-19. What I thought at the beginning of the pandemic was that, if we could change our diet, we should be able to sustain the problem. I had suspicions about what this whole thing was all about at the beginning. So actually, my wife and I had mostly already, of course, changed by that time. And I'm 90 as I speak here now. She's just 83. So we're primary targets for getting the vaccine. I didn't want to do that. I really thought that, if people could change their diets at that point in time, they could avoid the vaccines. So we didn't get the vaccine. We kept on the diet we got. We got tested positive for the coronavirus in about a year and a half. No problems. About 6 days in one case and 8. In those days, we kind of felt a little down and kept on working. But we, no vaccines, and we solved the virus, this coronavirus. We got the coronavirus, can't solve that, but we changed the diet. No problem. Let me show you a couple more things here before I leave. And this is from the first China study that we did in the early 1980s. It actually came out in the New York Times in 1990, actually. I want to show you sort of some data from that study that really supports this kind of thing I'm talking about in a way. Namely, what I'm showing you here is a relationship between, this is all from that study, the heart disease study, 6,500 adults, 35, 64 years of age, and so forth, as you can see there. The heart disease rates here on the y-axis, and here's amount of serum cholesterol. Okay, serum cholesterol. The amount of cholesterol we consume, if that's all there is not going to cause heart disease. That's been an intentional shift of opinion, to be honest, away from the fact that the real cause is animal food. So anyhow, serum cholesterol is a pretty good indicator of heart disease risk. And so some years ago in the 1980s, I was on a government committee at the time. We all were aware of this, that the range of cholesterol intake in the United States is considered to be okay, normal. It goes from 155 milligrams per deciliter, there's the terms right there, up to, let's say, 274, maybe even 300. So there's a line that has been used in the US to show the relationship between serum cholesterol and heart disease. And of course, their solution is take a statin, which deals with the cholesterol, but doesn't deal with the disease, really. So here we got the relationship of serum cholesterol with heart disease. I want to show you what we saw in China. Really amazing. In the U.S., we were saying at the time, you don't go below 150. If you get down there too low, suicide rates are higher. And colon cancer rates are higher, which is really nonsense. But that was the way of saying it here in the United States. In China, their low was 94. These are means, by the way, of counties and even lower. Their low was 94, the high was 62. So it turned out the line here for the US, it goes down as you decrease serum cholesterol. Heart disease goes down, as you can see there. The China study, in the China population, it keeps on going right on down. The lowest cholesterol level mean, just average, of one of the counties was 88, if you can believe it. And at that point there, in one of the counties at that, more or less at that range, only one person out of 340-some thousand deaths, I think it was in the records, actually suffered from heart disease. So heart disease is virtually not known in China as cholesterol levels go down. By the way, my friend Paul Esselton, we're good friends. He was at the house at the time. He was kind of looking at their stuff, and he pointed out, said, "Oh my gosh, there's only one person out of 300-some deaths here that died of heart disease." So that was the basis for the China study, which now I didn't think it would go anyplace. Been going, this is the second edition in 2016. It's been translated to 50 foreign languages. Now it's around 5 million copies. And I want to just finish this off by a couple of things. Our focus on protein, animal protein in particular, has been so so keen. I mean, it's in my mind, in our trade, and where I came from, everything else. I did my doctorate dissertation. We believe in animal protein, particularly, I say we believe in protein, of course. It is important. It's an important nutrient. But we believe that the best is in meat. When it indicates way back in 1800s, 1839 to be exact, this gentleman here, Gerald Mulder, a chemist in Holland, discovered for the first time a chemical in meat to account for the fact that the meat was useful in keeping a dog alive. He isolated it. He got that chemical out, had to get a name for it at that time. He named it as the Greek word proteos, which means of primary importance. And so that's the baptism. That's the baptism of the word protein, comes from the Greek word, right? And so ever since then, we've considered protein, meaning animal food, animal protein. We tend to think of it as of prime importance, and so it's been. It's that, but that in fact is really what justifies more than anything, nutritionally speaking, our production of livestock and for pigs and chickens and all the rest. My background, quite frankly, of this whole thing. So why? I mean, the story, the history of this story is fascinating. And it's worth a couple of lectures. I talked about it some with my grandson in the Future of Nutrition when we wrote that book in 2020. The history, you can go back and you see why we got so confused and why we're doing the really kind of dumb things we do. And so it impacts our whole system of medicine. I'll finish up just with this comment here. And I'm saying I'm giving you the shorthand version of a lot of information. So take it or leave it, but here's my summary of things. Our practice of medicine in the West, I call it reductionism. It's all focused on one cause, having one effect, operating one mechanism. It's one, like that. Just one item. And we think that way because if we can identify what that mechanism is, or if you will, or which disease we're talking about, then they go to work and give a drug. That's where the drug comes from. The drug comes from this concept here, reductionism. And so we invent chemicals. We can't use natural chemicals because we can't get patents for it. So those natural chemicals that might look like they have a little property, little effects, good effect in food. By the time we take them out and rearrange them a little bit and then give them, that's what we use to try to treat ourselves. That is the opposite of nutrition. I call it holism in the book that I had there that was shown in the intro, I think. I call nutrition a very different, I'm going to say animal, I can't quite say it that way, a very different concept from medicine. They're two opposites. One focuses on one thing at a time. That's what causes our problems and our soaring healthcare costs and all the rest. Whereas, hold on, this is a whole food. Eat the whole food. Eat the plant foods. It's a dramatically different universe. So in our current medical system, we think of one disease at a time. Each disease has its own properties, if you will. One cause, one mechanism. That's what we think about it. That's what we make a drug. When we think, we're going to take the drug and we're going to target it to a certain mechanism. As I showed you in our work, that I got my bias from, I guess you could say, my conclusion. Namely, I was looking for the mechanism. And there was no such thing as the mechanism for the most part. And we use these drugs that are not even natural, and they all have side effects, and certainly a cause of death. It's horrific. This is why nutrition is not taught in medical schools. Nutrition is holistic. We solve a lot of problems. Instead, we use lots of drugs. Makes a lot of money. So here we're making health. Here we're making wealth. That's a fundamental difference. If nutrition were taught in medical schools, there's not one medical school in the United States that teaches nutrition. Not with this concept whatsoever. So I'm sorry to say that my medical colleagues, they have very fine people wanting to do their thing and so forth and so on, tend to want to think and look at one thing at a time. Maybe using nutrient supplement, maybe using drugs, whatever. If it were taught nutrition, we could solve our problems, all kinds of problems. This is why public is so confused about nutrition. So as I say, I explained some of this in regards to history with my grandson, Nelson Tisla, graduate University of North Carolina, a good writer. And we tried to explain it here. Basically, where's nutrition going to go? Where's it going to go? First off, we have to understand what the word means, and then we have to teach it. We have to inform the public, and the public's not getting access to this. And the physicians themselves have almost zero. They not only have zero knowledge, they have a worse kind of knowledge because they tend to focus on one thing at a time. And that's not, in my mind, the way to go. It's crazy topics. So one last thing here, I've got an online course. We've got an online course based on a course that I taught at Cornell for a while. It's been in existence for a while, so it's associated with Cornell, get education credits. There's a link to it. It's been very successful. It's been the #1 online course at Cornell for many years. That's another story. But we actually segregated from Cornell, on good terms. But the cost of our course is too high. It's what the university required. And so we now have the same program, but for cheaper money. But more importantly, we've just about finished translating the entire program into Spanish. We've got about 27, I think it's 26 or 27 professionals in Latin American countries that are giving lectures in the same material. And of course, we have the English version, the Spanish version, and now we're just in the midst of really getting the Chinese version. We've got our friends in China are very active, working really hard to translate our whole course in here. And together, the number of people who are English speaking, Spanish speaking, or Chinese speaking names is somewhere in the neighborhood of about 2.2 billion. And we're keeping our fingers crossed. I think that I am the principal speaker at the Lifestyle Medicine Congress each year in China. So it's associated with that too. So we'll get a lot of exposure, I think, to this. And so I'm really excited about the possibility that this question concerning whole food, plant-based nutrition, its time has come. They can do so much, mostly just make us healthy, keep us healthy, or reverse our sickness. Thank you very much.
Great. Thank you so much, Colin. That was extremely informative and amazing as always. So, just real quickly for our audience, if people wanted to follow your work, or I don't know if you're on any social media platform, how would they follow your work or get in touch with you?
Yeah, interesting. I never, except one time I did with my son, but I never went onto social media. I've never submitted a single post. I didn't want to go down that track, to be honest about it. So I don't have a social media thing or a nonprofit, nutritionstudies.org. They have an outreach, quite a large outreach of people that we can contact that way. What can I say? So it goes through our Center for Nutrition Studies. It was put in my name, T. Colin Campbell, Center for Nutrition Studies. I think it's probably one of the best ways to do that. One of the things I really find exciting about this whole thing, there are really quite a number of people. I'm hearing, huge numbers of people who are doing the one thing that do it best. Try it. Simply try it. That's about the best selling point I think one can make. I get so many replies now of people having serious diseases and trying it and reversing it.
Great. Thank you. Yeah. And I'm glad to hear that the price of your course went down, because I'm definitely interested in taking it myself. So real quickly, John, if you could put the book back up. So if you're interested in getting any of T. Colin Campbell's books, you can go ahead and purchase them through the realtruthabouthealth.com bookstore. So here they are featured. And we have about 20 minutes left, so we're going to go ahead and open up the Q&A portion. If you'd like to ask a question, you can raise your hand, although we do have a shortened Q&A time. So we'll try to get to you if you raise your hand. So my first question is, since the China study has come out, have there been any reputable studies that have come out designed to understand the correlation between diet and health outcomes that either support the conclusions of the China study or challenge them?
No. I mean, you might think it's a bit of a bias on my part in this case, but there are lots of books that have been coming out from time to time, but they usually focus on, they're usually written by people without training in nutrition. That's my first point. And without having that background, that understanding what nutrition is, it lets some people to choose. Well, I got one here. I'm going to tell right now if I have it. I just got one the other yesterday. I don't see where it is right now. Oh no, well, I have it here. I'm sorry about it.
Well, you know what? You're going to be speaking tomorrow, so maybe you can bring it tomorrow. And we
Yeah,
can
there's one that just came out, and they sent me a copy, and I find it really kind of attractive, quite good. But Esselstyn, Dr. Esselstyn, a good friend of mine, he came out with his reversing heart disease thing. We kind of have worked together over the year on friendly terms. I can't really say. I should think of some more, but there's almost none. There's a lot of noise about this. I have to say that the one discipline in this area that should be at the top of the list, as far as doing the really positive stuff, are the chefs. The chefs. We have very good chefs. I've known several, and they've published books and stuff like it, including my own daughter-in-law, Kim Campbell, and my daughter. But Chef AJ and others. I want to put a big plug in for those people because they're sort of believe in this kind of thing, I guess. And one of the difficulties is people, they don't want to go there, and there's nothing not tasty, et cetera, et cetera. But I say some chefs are very good at making really tasty food with this kind of food.
Absolutely. And I think that when people get an opportunity to try food that tastes great and is healthy, it's much more accessible to them than just, knowing that plants, are healthier, but may not be as satisfying in their mind. So it really is important that way. So
can I say one more thing? I'd be remiss if I didn't say this. I'd really catch it. My daughter, who runs our CNS project, she had a cookbook called the Study Cookbook. So that's her, and our daughter-in-law, Kim Campbell. Yeah, I got to plug in for this.
Oh, no, absolutely. I don't want you to get in trouble. Yeah. So now when the China study came out, there was some, and not surprisingly, some debunking by somebody who, I've read some of your responses to that wasn't necessarily qualified. Can you explain what they attempted to debunk and then your response to their debunking?
Yeah, the cheap criticism at the time was written by an English major who, not in science, a young woman who was associated with a lobbying group in Washington, to be honest about it, who was promoting the opposite point of view. And they brought up the question. She did a nice job of explaining this sort of thing. Said the China study is nothing more than a bunch of correlations, and correlations do not mean causation. Well, that's true if we're looking for a single agent, but that's not the way health works. I talk about everything together. So when I start looking at the ratio of animal food to plant food, we see these remarkable correlations, all consistent. So that I want to debunk that notion that correlation does not equal causation. It's true in one sense if we're looking for a single cause of a single disease, but it's not true. We don't eat things that way. When we eat the whole food, it's a very different story. Then all of a sudden the correlation, you only have one factor on the one axis, and that's the ratio of the animal to plant. In that case, that correlation versus causation criticism should be debunked. There's nothing to do with this. So that's the first thing, my first reaction. I've got a lot of other comments too. There's an interesting thing. So we did that study in rats, showing that reversal. I mean, when we can reverse cancer in animals by decreasing animal protein intake, it's so dramatic and it's unmistakable. That did cause ripples, let me tell you, big time. I haven't seen a single study ever published that show the reverse. They can't do it. So if that is around, that animal protein does this, that, or something else, maybe in the short term, some of these things might look like they're doing something good. But in reality, we're interested in their long-term health, I think. And so any short-term effects can wash out really quickly.
Thank you for that. So Michael Greger will, who you may be familiar with, would often point out, like when studies are being done, that one of the limitations of the study is that it's done on rats versus humans, for example. Has there been any follow-up studies on humans with regard to the ability to turn on and off cancer through diet?
I have to tell you, I don't agree with that concept, by the way, not at all. Yes, we did 90% of the researchers in my time were using experimental animal studies at the time. That's the way you work with it. And I put that caution in the China study itself on page 42, to be honest about it. The question is this: do I ignore what we learned there that led in turn to biological plausibility in human studies? Do I ignore that? That's silly. That is really absolutely silly. Because the other way to answer that question is, I haven't yet found a group of people who are willing to change their diet, if you will, and then try some chemotherapy or try some drug or something like that, which the medical profession prefers. They're not willing to play with their disease that way to see if this works, that doesn't work, especially with respect to a drug. I have to say, I'm very being blunt about that. That's nonsense. And that is the model for the entire medical system. We work one thing at a time. They want to sell drugs. And, you're going to have an answer to every single condition with a drug. That's another criticism, because there are those who live on that principle, especially those who have MDs, because they haven't been trained in this area. And so they collect a whole bunch of facts, isolated facts, and they say, oh, this is good, this is good. That's not science. That's simply looking for something they like, and then telling the public about it. So I don't know how to answer the question. I'm trying to skirt. I don't want to get involved in personal criticism all more than I can help. But the concept that foods work together, that's nature, that's Mother Nature. And what I came to know, really, I'm really confident of this, is that Mother Nature is pretty fascinating. She's had a few million years to work it out. And she takes this enormous, infinite complexity, nutritionally speaking, of foods, the right kind of foods, and creates health, period, end of story. And, we can talk about one of those things at a time and get all kinds of opportunities to send out signals any which way we want. Some of them use that kind of stuff. Oh, we need meat, we need eggs, we need or something like that. It's totally out of context. The Greeks knew that, by the way, a long time ago. Aristotle, who was around 400 BC, who learned from Pythagoras, who was in the 500 BC. Aristotle said, the whole is greater than the sum of its parts. And that was one of the greatest statements ever made. You can't take out a part out of a very complex thing and turn around and try to fix the whole thing by working one thing at a time. It doesn't work that way. Sometimes if you see short-term effects, it looks impressive, but it's not the short-term effects, because it actually can delay the so I'm trying to summarize it, in a few short words, but I'm quite fairly critical, but of some of that kind of thinking. But I'll talk more about that tomorrow.
Great, we look forward to that. In your research, what have you seen the role of genetics playing? It does, I think it's often used as a scapegoat, for be able to sell food and say, oh, you can eat all this stuff, and if you get sick, it's because your genes, not because of the lifestyle you're leading, what you're eating, what you're smoking, etc. What is the role in cancer with regard to, of genetics with regard to cancer and other diseases versus lifestyle?
Great question. It's a very, very prominent question, very, very foundational. The people in the cancer business, and that's the area I mostly worked in, they have for years, decades, have said that cancer is a genetic disease. A lot of people say heart disease is genetic disease. What it means is that, you know, we're kind of doomed, depending on what our family background is, what our genetic background is. I don't mean to minimize no genetic effect, because there are some differences that you can see from time to time. But even for those who have high risk, high genetic risk, they can control their problems that are more likely to occur, maybe, but they can control it with the same formula, where it was high genetic. The genetic risk, the National Cancer Institute, NIH, for example, for years had on their website the number one thing: cancer is a genetic disease. Well, I've gotten funding from all of my funding. I've got handsomely over the years. I know that group very well. I said, wait a minute, that's not right. You just try to sell products, because if people believe that they're getting cancer or heart disease because of their family background, what are they going to do? Then they're going to turn to drugs. And so I basically said that's absolutely wrong. It's misleading. Actually, they took it down. You don't see that on there now. And I write in a new book I'm doing right now. I'm telling you a lot of these things in this new book I'm doing. It's just finished. I hope it's going to be coming out soon. I'm pointing out that, just in reference to your question, genetic determinism is, in fact, as you implied, is a basis for basically giving drugs, because a comment can be made, you know, to a patient, for example, oh, I'm so sorry, you know, you got it, it's in your family, and so forth and so on. You got to do this, you got to do that, kind of thing, instead of saying change your diet.
So with regard,
that's that first slide I was showing you. That's how I got into this field, because we had an animal model. Some people don't like it, but too bad. We got an animal model that started out with a genetic determinism. And what we found, it wasn't the genes that you can it initiates things, but what controls it is the nutrition that controls the expression of the genes. That's what matters. And we can do it that way instead of trying to get drugs to manage something and sell something. It's kind of silly.
So, so on that topic of genetics versus the actual expression of disease, Angelina Jolie famously had a double mastectomy after having a genetic test done showing that she had the BRCA gene. What do you think of those types of measures in response to finding out that you have something like the BRCA gene in your DNA?
Yeah, I know about a case. Somehow I got involved in a little bit, but at that time, that was probably one of the best illustrations of a gene that actually does cause some difficulties. The BRCA gene does raise risk. There's no question about that. But the important answer to that is to don't worry about that. Just be more strict about your nutritional experience. In other words, your challenge might be somewhat greater. And of course, if everybody's eating the wrong food when a BRCA gene comes along, that's going to really get a lot of people, you know, who have that gene. But on the other hand, even for those who have a higher genetic disposition, we can control that. That's why in the animal studies I was showing you again to illustrate the point, all those animals were high risk genetically for getting the disease. But did you notice the ones given the plant protein, they did not get the disease? It's that simple. So, you know, these genes do play a role. I mean, everything starts from genes, everything. As we're talking here, we're talking because of our genes being activated, you know, some kind. So, you know, that's part of human nature. We have genes for this, that, and everything else. And sometimes they work together and so forth. But the real question is not that whether or not we have the genes or don't have the genes. We know it can make a difference. It's a question of how do we treat those diseases that are high risk compared to those who might be lower risk. Same formula. Eat the right food.
So now I realize that you're a nutritional biochemist and not a medical doctor, but if you are, or in your opinion, in your non-medical doctor opinion, because I just want to, you know, be safe. If someone came to you with a, you know, BRCA gene, or knowing this case, would that be even a viable option, or would diet be the way to go and not the double mastectomy as a prophylactic measure?
Boy, you're asking a really, quite frankly, didn't know it, but you're asking a loaded question.
If you don't want to answer it, you don't need
No,
to.
no, no, I'll answer. Don't worry about it. I've spoken to medical schools in more than 40 states in the United States, all over the place. In fact, I was a representative of the American Medical Association at one point. And what I learned in that experience, a lot of fine people, that's not the issue. It's what I find the fault I find is that the umbrella under which they live and they're taught is very different. And so they go to school to get that. They don't get nutrition because basically the industry doesn't want them. So unfortunately, the people working in the area of medicine are basically trained how to use drugs for this, that, and something else. I've spoken in some occasions when I go into the room, I might have to wait for the next speaker to finish up. Usually a drug representative there telling them how to use drugs. And so there's a contrast between these two concepts. Drugs are based on one thing working at a time, very strange chemical, as opposed to food, on the other hand, working differently and better. Yeah, I know a lot about the medical system, and I think I know more science than they do, quite frankly.
So thank you. So we've got about 2 minutes left. So I just want to ask you, just we only have 2 minutes to answer the question. In your book, The Low Carb Fraud, and where you critique low carb diets, how do you interpret the success stories that are claimed from diets like Paleo and Keto?
Yeah, again, it's a concept that was developed by Dr. Atkins, if you will. He died himself of heart disease when he was about 72 or so. He was arguing that that decreases calorie intake, which can have a benefit in the short run. And so what we see with people starting a low carb diet, for example, an immediate effect in many cases looks beneficial. They lose some weight. They're not consuming the same amount of calories, right? And all looks good. But if you look at those people in terms of a lifetime threat, it's just as high as the others. It doesn't mean anything. There was a guy who did the Paleo diet. Also, he and Larry King he and I on his show debating each other. We became sort of friends, but yeah, I know that game plan. It's a way of saying, hey, it's not so bad. We need to have some high protein, stuff like that. It was kind of a defense of the animal protein industry when they were doing that. And I know that history of that and the evolution of those ideas quite well. I'm old enough to know. And so the Paleo diet and the Atkins diet, if you will, that kind of thing is based on the same premise. Just eat lots of protein, just cut down on your starch or your sugars, especially, or your fat, well, especially sugars. And that's where the problem is. Yeah, in the short term, we see some what appear to be beneficial, results. But, forget it. They still are going to die if they're still using the same protein or more. They're going to be worse off.
Great. Thank you for that answer. So I know some of the audience had some questions, and I just want to kind of promote tomorrow. We're going to have Colin Campbell back at 9 a.m. for another presentation. So I think we'll have a little bit longer for a Q&A tomorrow. So if you'd like to ask Colin Campbell some questions, you can join us at that time. If we can, so we're just about done. So if we can unmute the audience, so they say thank you to Colin Campbell.
Answer comes to you.
Thank you.
Thank you. Appreciate it. Myself, thank you so much. Part of the day. How about that 1 year? I'm trying to give you another chance to do well. I'm good, so please.